So now for problem number 5, it says a charge of 0.050 coulombs moves vertically in a field of 0.08 Tesla. That's a magnetic field, I'm assuming, because it's in Tesla. That is oriented 45 degrees from the vertical. What speed must the charge have that the force acting on it is 10 newtons? Okay, so this one, the relationship between all of these things is that the force should be equal to the charge times the velocity times the magnitude of the magnetic field, and then sine of theta. And so let's go through and try to figure out what we have. Well, we have the charge, right, which is 0.05 coulombs. We have the magnetic field, which is measured in Tesla, which is 0.080 Tesla. We have theta, the angle, which is 45 in this case. And it wants to know the speed, and it gives us the force, 10 newtons. So everything's in its correct unit. So let's take this equation and solve for V. So to solve for V, I just basically got to divide both sides by QB sine of theta. Whatever I do on one side, I got to do on the other. All right. So let me catch up to my thoughts here. To find the speed that the charge must have that a force acting on it is 10 newtons. I think we just plug the numbers in. Yeah, that's right. So I've got 10 newtons, so let's do it on this side. 10 newtons divided by the charge, which is 0.05 coulombs, times the magnetic field, which is 0.08 Tesla, times sine of 45. All right, and so the velocity should be, if I were to do that on my calculator, 3.5 times 10 to the third meters per second, I think. Let me double check my math here. Yep, looks right to me. Any questions?